Hello, everyone. My name is Maria, and I am the founder and CEO of Ecolens, which is the company that developed and launched techFiesta, our online hackathon and developer challenges platform. We are the organizer of this training with amazing help and sponsorship by Concordium. You see here Bogachan and Kasper from the Concordium team who will give the training today. And before we kick off, I would like to present a couple of slides so you know who we are and what we do. So just a second. I will just a second because I need to pull up my slides. I'm sorry. All right. Let me share my screen now. Okay. I hope you can see my screen, right?
Yes.
Yes, Maria.
Okay, perfect. Right. So we're here today to learn Rust basics, right? And how to launch smart contracts on Concordium. This is why we're here today. And this training is sponsored by Concordium and powered by Ecolens. What is our agenda? So today we'll kick off with an introduction of techFiesta as a developer activation platform. Then we will have an introduction to Concordium. After that, we'll have the session about Rust basics and intro to Concordium smart contracts. Then we'll have the opportunity to answer some questions and we'll have a 15 minutes break. And after that, we'll have a second session, testing and deploying Concordium smart contracts. This is, of course, super important. And after that, we'll again have a Q&A session. All right, so what is techFiesta? techFiesta is an online hackathon and developer challenges platform where you can participate in developer challenges and hackathons, obviously, that are sponsored by different Web3 protocols. There are different bounty awards in each of them. And what you can do is learn how to deploy smart contracts, how to build projects on these protocols, learn from other hackers that are participating, get to know the protocols, get to know the people within the teams, of course, get amazing opportunities such as access to grants, maybe also access to jobs with the protocols or with the ecosystem of the protocols, and launch your own product. So this is an amazing opportunity for everyone that wants to start working in the blockchain space. So please take advantage of it. Here is how it looks like. So we have a list with many hackathons and developer challenges. The green ones are currently the active ones. So we have currently 5 things that are active that you can participate in. And today we're launching the 6th one, which is the Concordium Developer Challenge. It will be launched during this training and you can immediately participate after the training. And with this QR code, you will go to techFiesta. So what you have to do on techFiesta is just simply pick your challenge or pick the hackathon you want to participate in, create a very quick profile, and then start hacking, start coding. We're very Web3 focused. So that means that we work with Web3 protocols and Web3 companies. There are a couple of Web3 elements on the platform as well, such as on-chain payment, for example, and verification with your wallet, so you can receive your rewards directly to your wallet. We have a cooperation with Concordium. We have started to work with Concordium to implement some amazing features built on the Concordium chain and using the Concordium infrastructure. We'll have also identification on Concordium. That means that for some hackathons and developer challenges, it's required to identify yourself, but it will be on-chain identification where your data will be stored on chain and it will be encrypted. And we can just check, for example, which is your location, because some of the sponsors, let's say, want to have people specifically in Africa or people that are specifically located in Europe. So this is one of the things we're doing together with Concordium. And the other thing is distribution of soulbound tokens. For every participation that you have in a hackathon or developer challenge, you will receive a unique soulbound token, which will also be part of your ranking on techFiesta, and you can win prizes and like amazing other things with this ranking. But this is something that's coming up next year, and we'll have another conversation about that. But yeah, with no further ado, I want to now give the word to my colleagues from the Concordium team. Boga-chan, please introduce yourself and introduce Concordium.
Thank you, Maria. Thank you for your kind words. Hello, everybody. My name is Bogac, actually. I am a technical product manager working for Concordium for 1.5 years now. I don't want to hijack the meeting. I will just very briefly explain what is Concordium, why we do what we do, and everything. So Concordium is a public permissionless layer 1. Recently, we have changed our consensus to Concordium BFT, which gives us officially 1,200 transactions per second, and our block time is 2.1 seconds on average. We have stable transaction fees for simple transactions like transferring CCD. CCD is our coin, and our smart contract language is Rust. But apart from all of these performance metrics, the biggest key differentiator is the ID. As Mario already mentioned, we have identity layer at the protocol level. Everything we do is to create a safer digital world. And we believe that we are addressing one of the biggest problems or obvious gaps in the industry, which is accountability. On all those giants, Ethereum, Solana, Near, the only thing you need to make a transaction is to create a wallet, right? Basically, you just need a public key and private key pair. Anybody can do that. Basically, when you are dealing with someone, you actually don't know who is behind that particular account. It could be a bot, it could be an imposter who claims himself someone else, or it could be a person who is trying to steal your money. You can easily get involved in a NFT rug pull project, for example, or a scam one, and your assets can be stolen. We can't stop these attacks. I don't say it's the only reason, but we can't stop these attacks because, let's say, bad actors, they know it's almost impossible to track them down because they are not accountable, so they are doing it. But in Concordium, things are slightly different. In order to create an account, you have to have an ID. And just like other chains, we have our wallets, like browser extension, or mobile wallets, like MetaMask, for example. Using those wallets, in order to create your account, first thing you need to do, you have to provide, you have to take a selfie, and you have to take a photo of your passport, driving license, ID card, or soon NINs from Nigeria, national identification number, will be available. And your wallet transfers these assets to the institutions we call identity providers. These identity providers, they are in data business, data security business. They do KYC services and many other services. But for Concordium, they issue an ID object for you, and they transfer it back to your account. At that moment, basically, from that moment, you can create an account and you can transact on Concordium. From technological perspective, from Concordium size, you are just one of the other pseudo-anonymous addresses, bunch of characters and numbers. Concordium doesn't know who you are. Your information resides in your wallet, and the identity providers has them, and they protect them in an encrypted way. But at that very first moment, you have a direct proof. You are proving that you are human, right? There's a direct proof of humanity. That's one of the biggest advantages or the pillars that Concordium is standing on. The first out of 3, I would say. The second one is there is a mechanism in place that we call anonymity revocation. So there are institutions, some legal parties involved in this flow, and they basically, if you can prove that you somehow scammed by a scam project, someone is rug pulled you, someone is fooled you, and if you can prove that by a court order, you can initiate this anonymity revocation process, and then those bad actors' identity can be revealed. So there's a natural disincentivization mechanism for the bad actors. It doesn't make sense to build a scam project on Concordium. And the last and one of the most important ones, as Maria mentioned, is basically we do provide some libraries to you can use them in your dApps, and using those libraries you can create and ask zero knowledge queries to the end user. So for example, when you create this ID object and your account, there are attributes or credentials attached to your ID object. This could be your name, surname, nationality, birth date, everything in your ID card, for example, right? So you can create zero knowledge queries to ask to your end user. If he's okay with that, he can share it. For example, if you're building a beer store, the first thing you need to check that the end user, he should be older than 18, right? If you want to be, compliant with the rules. So you can ask directly to the end user, hey, this platform wants to know if you're older than 18. Are you okay to share this information? You can accept or you can reject. It doesn't necessarily you have to share the information itself. The platform doesn't need to know your exact birthday. But using the zero knowledge query, you can say that I'm only older than 18. I don't want to share my country age. Or as Maria said, if there is an event that requires being a citizen of some African countries, let's say there's a list of countries in your app, and then you don't have to exactly share your nationality. You can only verify that you are from one of those countries with our ID. I don't want to confuse you too much, but if you have any questions, if you have any projects that you may want to utilize the ID or Concordium in general, you can reach out always, and we will be gladly assisting you. Thank you, Maria. Let me hand it over back to you, or directly Kasper to my colleague. Let's kick it off the training session.
Oh, thank you, Bogac. It's yeah, I'm Kasper. I'm an engineer at Concordium. I'll just share my screen here. 1 second. Where did you do that? All right. Here we go, the green button. Okay. Okay, and I haven't done that before, so I need to allow it.
So while Kasper is trying to share his screen, maybe I can say a couple of things. So guys, if you have any questions, please put them in the chat. We'll of course have the Q&A session, but maybe it's easier if you have the questions to collect them in the chat and then go question by question, so we're quicker in the Q&A session.
Possibly there's an issue with the preferences of the Zoom. Let's give Kasper a minute. He'll be back.
Okay, no problem. Maybe you can say a few words about what projects are currently being built on Concordium. Yeah, some interesting use cases that you currently have. I think that's always very interesting to hear.
Okay, he's here, but if you want me to, I can start, of course.
All right. I think now I can share my screen. Sorry.
Okay, let's start.
Some settings that I had to allow. That's all right. Here we go.
Guys, we started receiving questions already, but okay. Let's kick it off. Yeah.
Yeah. Do you see this? Some big Concordium thing? Yes, good. Okay, yeah, so sorry about that. Yeah, I'm Kasper. I'm an engineer at Concordium, and today we're going to cover Rust and smart contracts. And yeah, you can ask questions during if you have some urgent questions. Otherwise, we'll take we have two different questions sessions in the end. Yeah, in the end of each session. So what we're covering is Rust and the lifecycle of smart contracts on Concordium, and how to set up your developer environment for writing smart contracts. Then we'll build the smart contracts, and we'll have a break. Maybe we'll see how far we'll get. Otherwise, we'll have the break in between here. And then we'll test some smart contracts and set up our wallet and put the contracts on the chain. And then we'll have some more questions. So there'll be some time for questions here. All right. So Rust has this mascot, the official mascot, which is called Ferris. So that one will follow us along. So what is Rust? It is a systems programming language, so you can build an OS in it, like C and C++, which is quite cool. So you can build all sort of programs in it. It's the most popular language 7 years in a row. Maybe it's 8 now, actually, according to the Stack Overflow developer survey. It has a very strong type system, so everything has a type, and the compiler will catch a lot of your mistakes. And it has some really nice high-level abstractions, which differs a lot from C and C++. And these come at 0 runtime cost because of some neat ways that they've implemented it. Yeah, so the cost comes at compile time instead, but Rust is still quite fast to compile. And they use this thing called ownership model for memory handling, which differs from other types of languages that have garbage collection or manual freeing of data. And this ownership model also gives a lot of strong guarantees against common bugs in your code, especially when you're doing concurrent code. I'll dig into this memory model a little bit. So as you might know, in languages such as C, C++, you have this manual handling of memory where you use alloc and malloc, and then you have to use your memory and then you free it in the end. And then we have a lot of languages such as Python, JavaScript, etc. And they have garbage collection. So this is like a program that runs in the background and it runs and cleans up your memory. So these languages are actually really poor for writing something like a operating system, because in order to run the garbage collector, you need an operating system to run it on. So you cannot just you cannot write the operating system in here when you also need the garbage collector to run it. So for that, you need a language such as C and C++ or Rust. And Rust is a nice choice because it's very ergonomic and people really like it. Yeah. And so the third way of handling memory is with Rust's ownership model. So there's no manual freeing of data, no freeze here, and there's no garbage collector running. So that's quite cool. And the way that this works is by having 3 rules that are checked at compile time. So one is that each value has an owner, and there can only be one owner at a time. And when the owner goes out of scope, the value is dropped, i.e. freed. Dropped is the Rust word for free. So here we have an example. Here we have a scope delimited by these curly brackets. So here we are saying the variable s, let's assign this string hello to it, and then we can do some things with s here. And then once the scope finishes, the s goes out of scope, and then the value is freed. So hello is freed from the memory automatically. So this is checked on the compile time, and that's really nice. So we didn't have to, of course, we're allocating it here, but we don't have to free it manually, and there's no garbage collector running. So the compiler basically automatically inserts a free statement here. To understand this a little bit better, and also to understand some of the choices in Rust, it makes sense to briefly look at the stack and the heap. So the memory on your computer, like the RAM available for program, is split in 2, the stack. And the stack is for data of known sizes and fixed sizes, such as numbers, bools, and pointers. And you put them on top of each other like a stack of plates. And you use last in, first out. So, the topmost plate is the one you can take off the first again. So this is very quickly put in take plates. Whereas the heap works in a different way. So this is for data of variable sizes and changing sizes as well. So this is for things such as strings and lists and trees, etc. So bigger types of data. And it's less organized. It works by you requesting a certain number of space, and then you get a pointer to it. And this pointer you can then store onto the stack, actually. An example for this is like getting a table at a restaurant. It's like you go to the restaurant and then you say, hey, we need a table for 6 people. And then they'll show you to a table, and this is table number 4. And this number 4 is then the pointer to the table. And the pointer can be stored in the stack. But following pointers is quite slow, if you compare lifting plates off and off on and off a stack, then compare it with you coming late to the dinner with your friends, and then you have to ask the waiter, and they say, oh, it's table number 4, and then you have to go all the way to the table. So that's, yeah, if you keep those two images in mind, then that's helpful. So the heap is lower. Okay, then back to the ownership model. So here we have some Rust code. We have a variable x equals to 5, and then we say y equals to x, and then we try to print x and y. And if you run it, it prints both of them. Okay, so that's, you know, exactly what you expect, right? And then we try to do the same with a string. So we say s1 has the string, owns the string hello, and then we say s2 equals to s1, and then we try to print s1, and then it says a whole lot of things. There's an error message here. The error message in Rust are really nice and easy to understand once you get into it. But there is an error, and that's a bit confusing at first. So it says something about the value borrowed here after move. So the difference here is actually related to what we just talked about the stack and the heap. So numbers have a known and fixed size, and they live on a stack. So they implement this copy trait, and the copy trait is an interface in Rust. So Rust will just, that's faster than doing something pointer. Whereas a string have variable size and live on the heap, so those are more expensive to use and move. So instead of creating a copy of the string, which is expensive, especially for large strings, Rust does something else instead. It moves the ownership. So now it says that, so we don't move anything in memory. We just say the new owner of this string is now s2. Okay. So writing Rust, you'll eventually run these sort of property, which is the part of the Rust compiler that checks these sort of rules here. So how do we actually get around it? Well, one thing we can do to fix this is that we can structure our program so we don't print s1. And that's actually not a joke. Over time, you will learn how to structure your program such that the compiler is happy with you.
Kasper,
the second thing you can do is to use the clone trait.
Can you hear me?
Something's wrong?
Something is wrong. Maybe you can turn off your camera. There's
Yeah.
Yeah, there's some lag on your side. Yes, maybe we can try this way.
Okay. Is it better now?
I think so, yes.
Okay. Okay, so you see the screen again. Is it decent quality and everything?
Yeah, everything is perfect.
Okay, good. Thanks for pointing that out. Okay, so yeah, so the second way to fix this is to use the clone trait. Again, that's an interface. So here we added the clone, and then we are very explicit about saying that, okay, now we're actually moving or making a copy in the heap of this string. And then if we run it, it works. The third way to go about it is to use references. So references are a big thing in Rust, exactly for this reason. So you have references are like pointers. So you use them a lot, and it also helps guide the design of your program, and makes it easier to read for a lot of things and reason about what a program or what a function does. So one thing you can do is here we have a function where you write fn and then a function name, and then it takes a parameter s here, which is a string. So here it actually transfers the ownership. So remember that there's always one owner for a value, but here we are saying that this function, when you call it with a string, then it takes over the ownership. So this s now owns the string here, and inside the function you can use the string, and then when s goes out of scope, the string is dropped. That's similar to what we saw before. But we can actually also borrow things. So we can lend out, temporarily say like, hey, you can use this thing, but I still own it. So here we can borrow immutably. So you'll see this ampersand here, and this function will then borrow the string, and then it can use the string, but not change it. It cannot mutate it. And after the function is called, S is still alive. So the memory in the heap is still there. And then you can borrow mutably. So you'll see that here there's a ampersand mute. So that means that you don't get the ownership, but you have like a mutable reference to it. So you can then change the string, and then once the function finishes, the string is still alive but has changed. So that's something also in Rust. Things are immutable by default, which means that you cannot change them unless you make it more explicit and add the mute here. Okay. So I think we'll cover the rest in practice, when we get coding. But first, we'll look at the lifecycle and structure of smart contracts. So on Concordium, the on-chain language is WebAssembly, or WASM for short. So you typically write your Rust programs or write your smart contracts in Rust, and then you compile it to a WASM module. And there can be one or more contracts in each module. So it might make sense for you to have multiple contracts that are related in the same module, so they can share some code, for example. And then what you do is that you deploy the module. So here we have on the left side here, we have the off-chain, which is just on your computer. And on the right side, we have on-chain, which is on the blockchain. So you deploy the module onto the chain, and then it gets a module reference, which you can identify it by, which is a hash of its contents. And then from there, you can initialize one or more instances from this contract. So you can initialize, as many as you want. And this makes sense for a lot of different types of contracts. For example, an auction contract, where you can have multiple instances, each representing the bidding for one single item, for example. Contract instances are identified by their contract address, which is 2 numbers. It's an index and a subindex, and the subindex is currently always 0. But so you can just identify it by its index here. So 42 and 43, for example. And they also have a name, the contract, and then you can update them according to their own logic. And this logic is stored in the receive methods, which are like instance methods in object-oriented programming. So you can see that you initialize it, and that you do that with the init method. That's like the constructor in object-oriented programming. And then once you've updated or initialized an instance, then you can update it with the receive methods. It also, the instances also store a reference to the module, which is where the code lives. And then they have a persistent state, which is persistent. So between calls, they can use the state and save things. And then they have a balance of CCD, which is the native currency on Concordium. Cool. Next up, we'll set up the environment for smart contract development. So the tools you're going to need are Rust, of course, and then the VS Code extension, Concordium smart contracts. You don't have to use this. You can do all the same things with a tool called Cargo Concordium, which the extension actually uses underneath, but it is quite easy to use the VS Code extension, and that's what I'll show here. Our developer documentation explains all the options you have. So for installing Rust, you go to rust.rs, and then on Mac and Linux, you just copy this command and run it in a terminal, or on Windows, you have to download and run one of these executables, depending on your bit. And from this, you get 3 things. You get the Rust-C, which is the Rust compiler, and you get Rust-Up, a tool for updating your the compiler and your tool chain and these sort of things. And you also get Cargo. And Cargo is the package manager for Rust, and this is the tool that you'll use most frequently. It can also compile the tools, your program for you. Okay, and for the VS Code extension, you just go into VS Code and click on the extension tab here, and then write Concordium smart contracts and click install. Cool. Okay, so now we'll build a smart contract, and we'll do one for voting. So first, a bit of fun graphics to explain what it is we're building. Imagine that you've seen something about a song contest, for example, Eurovision. I think maybe there's something called Africa Vision, I'm not sure, but there's at least one called Asian Vision as well. But it's a song contest. And maybe you're excited about it, but then you start thinking, okay, how is it actually, it works when you vote for this? Because there are these rules saying that you cannot vote on your own country. And that makes sense because then the population size would matter, right? Then a tiny country would have no chance of winning against like a giant country in Europe. Like no one would win against Germany, because if Germans could just vote on their own country, then of course they would win, right? And then you might recall that Bogarts mentioned something about the ID feature here. And when you create an identity in Concordium, all of these things are noted down about you in an encrypted fashion, and we can actually use that to create a very safe way of voting for these contests. So that's what we're going to do today. We'll first build the smart contract, which is a very basic voting contract, and then in a future session we will show how to use the DEP or a DEP to actually check and verify that the person voting is not from the same country as they want to vote on. So the contracts will be quite simple. We'll initialize it with a few things, like a description and the participating countries with 2 letters and the end time. And then we'll update the instance with some receive methods. There'll be a vote receive method, which takes a voting option, for example, SE for Sweden, and then it returns OK or an error. And then there'll be a view method for returning the tally of the votes, like how many people voted on Denmark, how many people voted on Sweden, etc. Okay, so let's get coding. Let's just see. Open up. Do you also see the VS Code now? Is it the full screen I share?
Yes.
Yes, great. Okay. So yeah, I installed this Concordium smart contracts extension, and with that we can actually, if you press F1 or open up the panel here, then you sorry, there's a zoom thing on top. Okay, from here we can actually initialize a smart contract project. So let's try to do that. Let's just do it here. And then it opens up this terminal window where you get a few options for a few different templates that you can use. So here, like the sys2 is for like an NFT standard. And then, yeah, we'll just use the default one. And then we'll give it a name. Description. Okay. And then we get this. Go. Then we got this project. So is it large enough? Maybe like this. Yeah. Okay. So this is the project that we just generated from a template. And this is a typical Rust project. So we have a cargo.toml file. This is like a package.json, similar to that. And we can see here we have some some different things. Our dependencies, Concordium std is standard library for writing smart contracts, and we have Concordium smart contract testing here, which we'll use in the second session here. And then we have a source folder with the smart contract, or at least some sample code for a smart contract, and then we'll have a test. We have some tests in here. And there's also, this is target, this is like the build folder. That's when you run cargo build. And then we have some deploy scripts, which I won't go over now, but you can use that when deploying if you want to. Okay, so let's just remove a few of these things, and then let's start writing a smart contract for this. So here we have a structure, which is like a record, and it's public. Again, in Rust, everything is private by default, so you have to make it public if you want it to be public, which we want for the tests. And remember that we wanted a description, so we'll add some fields here. That's also made public. Do we have a question?
Yes, I have a question.
Yes.
Sorry, I missed how you created the folder.
This folder?
Can you? Yes, the entire project.
Yes. So I ran. If you press F1 in here, then you can run. Then you can run this different tasks. I think it's called and here we have a number of different tasks from the Concordium smart contracts extension that we installed, and one of these are initialize a smart contract project. That's what I ran, and then it asked me, which template to use, and we chose the default template. And then I got this folder with all these contents.
Okay. All right. Thank you.
Yeah. Great. Good that you asked. Okay. So we are creating the state of our contract, and it's a structure. It's called state, and it has a few different fields. So it has a description, which is a string, and then it has what else did we say? It has some options, which maybe it should be a vector of strings as well. Maybe we can make a type alias, so we can. This won't give us any benefits in terms of the compiler catching things for us, but they will make it more clear what we're talking about. A voting option here. So this could be like, DK or Italy or whatever. And what else? Then we need an end time, which is a timestamp. So when should this election end? And then we'll have some ballots, which will be a B-tree map from account address to, let's say, voting index. So voting index will be a U32. So voting index would be okay, so a voting index would be like an index in this array. So it could be, this would be index 0, and this would be index 1 if it points to this one. So instead of storing the strings in here, we'll just store the indexes into this options vector here. Cool. And this is a map. So this is like a, map. I think you also call those records in other languages, but our dictionary, mapping from account address to voting index. Cool. Now we have our state, and we'll then write our init method. Let's just put this down here. We'll write our init method. So an init method is created by the to write that, you use this init macro. So remember, this is how you write a function, and then on top of the function, you can write different macros up here. And here we're using the Concordium init macro, which helps with allowing you to write very simple looking contracts, and then it has add some boilerplate on top of that. So everything works on chain. And here you must give it a name. Let's call it voting. And that's, I specified this when during that terminal wizard thing when I initialized the project. The init method has two parameters: the init context, which has the who's trying to, like, which account is trying to initialize this, and these sort of contextual informations. And it also has a state builder, which is used for creating advanced types of state. It returns the result with the initial state, and the result is an enum. Looks like this. So it either returns OK with a T or an error with an E. Okay, so that's a lot here. So an enum is like, yeah, I guess you know enums from other languages, but in Rust they're really powerful. You can do all sorts of things with them. So here we say that this enum is generic on two different types, a T and an E. And then there are two different variants of this enum. So one is OK, which has a T inside it, so whatever this type is. And then there's an error, which has an E in it inside. And enums are, as I said, are really powerful. So you can do like a common thing would be like, you can make a user enum, and then it could be anonymous. And then there's, maybe they just have an ID or something. So anonymous users, they just have an ID, but actually registered users, they have an ID, and then they also have a profile picture, let's say that, and then it's some string or something. And then you have really clear distinction between what kind of data is related to anonymous users and what kind of data is related to registered users. So that this is really cool. You're going to love enums, Rust's enums. Yeah. So an init result is just a result that returns your state, or it rejects. But yeah. So that's it. Okay. So what we're going to do is to read the parameter given, and then we're going to create the initial state. Okay, so what parameter should we be expecting the init parameter here? We should say that we want the description. So here I'm defining a new struct because we won't include the ballots here in the init parameter, since we're just going to create like an empty map for the ballots, since there are no votes initially. So there will be an overlap here. Voting option, and then end time. Okay, and so let's see, parameter, which is an init parameter. Then we can use the context here. So the context also gives us access to the parameter cursor, where we can try to get or read the parameter that someone passed in while trying to initialize this contract. And here we're using this question mark, which is quite nice. So what it does is basically, it's the same as if we wrote this here. We're saying it's doing a match, it's like a switch case. So if it's OK, get also returns a result. So if it's OK, then there's the parameter here, and we are returning the parameter. But if it's an error, some error, then we want to return early and return an error. Yeah. So this sort of thing is very in Rust, where you where you get a result back, does the file exist or not? And so if it's reading a file, then okay, I got the contents of the file, or hey, there was an error, the file doesn't exist, or some kind of thing. And this pattern is so common. You also often need to like nest them. So Rust have a different way of handling that, which is very cool. So you can actually use this question mark instead, which you'll see. So let's do, which does the exact same thing. Okay. So these two are identical. These 3 lines, 4 lines, and then this line. Okay, so now we have the initial parameter, and then we'll create the initial state here, and then let's say the description is the parameter description, and then what else do we have? The options is the parameter options, and we have the end time, which is the parameter. And then we have the ballots, which will be a new B-tree map here. In Rust, most types will have a new method for creating it. So we actually need here B-tree. Okay, and then we can return OK with the state. So this init macro actually does something here. So when this method returns the state, then the init macro takes over, and then it actually saves the state on the blockchain. So that's something that you would have to do manually if you didn't use this. So that's very nice that it will just return the save the state that you return. So this is the initial state. Okay, so then now we are able to initialize our contract. That's pretty cool. It's very basic, right? It just takes in an init parameter, and then and it can place something here. It just takes the init parameter, and then it creates the state and returns the state. So here it complains that it doesn't know how to deserialize this init parameter. And that makes sense because we actually didn't derive that. So that's something we have to do here. We need to derive the code for deserializing and serializing this sort of type. And we have the same thing for the state here. So serializing from these structured Rust types into binary format, or deserializing the other way. And we'll also add this schema type, which is similar, but that's for allowing us to use JSON schemas at a later point. Or sorry, not JSON schemas, but using JSON, so you can write in JSON and handing that in when you want to initialize your contract. We'll see that in the second session. Okay, so with this out of the way, we are ready to create our first receive method. So we already got a receive method down here. We'll just remove the code here. Okay, so here we're using a receive macro, and that's those are the 2 basic macros that you need: the init macro for your contract initialization method, and then 0 more receive macros for your receive methods. So here we're saying this receive method belongs to the voting contract, which matches up here, and the name is no, it should be receive. Let's call it vote, and then the parameter. Let's say that it takes in a voting option. So this could be DK for Denmark, and then it returns. It might return an error, which is this error. And these 2 parameters are used for allowing the schemas, the JSON schemas to work. So you can use JSON when sending in parameters, and it will be able to pass the returned error code into JSON, so it's easy to read. Actually, that reminds me, we need up here also to say that this expects an init parameter. That's for the init method. Okay, and then it's mutable. By default, receive methods are not mutable, so they are immutable, and that means that they cannot mutate anything in the state. And that's quite useful because you want to be very explicit about when you are mutating things in the state, as that's when things usually can go wrong. So, but for this, since we are voting, we want to mutate the state. We want to record that someone has voted. Okay, so what are we doing here? We are saying, Bogus, can you remind me when the question session was supposed to start? Is it at 30:30?
Let me check the agenda.
It's so
Wait.
in 3 minutes we should start the Q&A. We have
Okay,
collected
okay.
a lot of questions already, yeah.
Okay, that's fine. I mean, we'll cover the rest in the second session. There's more time there. Okay, so I think in 3 minutes we can do part of this at least. Cool. So what are we doing? We're saying that in the voting method here, we want to check that the election hasn't expired. And we want to check for simplicity that only accounts can vote, not contracts. And then we want to check that the then we want to read the voting option parameter. And we want to do, what else do we want to do? Then we want to add or update the vote for the account. So we'll allow that they can also update it. And then we'll return okay if everything went well. Okay, so let's check that the election hasn't expired. So the context here, yeah, we should go over what a receive method actually has of parameters. It has a receive context, which, for example, who called this method, which account or contract, and also like what is the current time, these sort of things. And then it has a host parameter, which gives you access to the state, but it also gives you access to calling other contracts and sending money to accounts and these sort of things. So that's quite nice. So we'll just check that the election hasn't expired, and then we'll take some questions. So we'll say that if the slot time, so that's the current time, if that is larger than, then we need the access to the host here, larger than host state end time. Yeah, so if the current time is larger than the end time, then we cannot allow this vote. Then we'll return an error. And what kind of error? We will return an, let's say, yeah, voting finished. And this is actually this error is this error enum up here. So this is a more typical kind of enum that you'll see. You know, you have one kind of error and different kind of error. We are not using this one. So let's say that it's voting finished. Cool. Yeah, and it expects that we return okay at some point. Cool. Okay, let's take some questions then.
All right, thank you so much, Caspar. We have a lot of questions, but some of them have been answered by Theo in the chat. So I'll just read out the other ones that has not been answered yet. So yeah. We have a question from Simon. He's asking what distinguishes Concordium in the realm of Web3 technology, and how does its approach contribute to the evolution of decentralized applications?
I guess this is also answered by Theo, but
sorry,
maybe
I couldn't hear.
Can the rest? Can you hear me, guys?
Yes,
Or
yes,
is
I
it
can hear you.
okay? Then let me take this one, Prosper. I see a lot of questions coming from the same angle, and the specific question that you asked or the Simon asked is already answered by Theo. But there are some confusion about the identification and some other stuff. So let me clarify that part first. But first, as Theo said to Simon's question, basically, we appreciate and we respect this brilliant data structure, and we provide an amazing platform, for the dApps, and they can use it as is on any other chain. And we have a great TPS, really good block time, 2.1 seconds. But apart from all these, as I said in the beginning, we are trying to address the biggest missing puzzle piece as the accountability. So our devs, our users, they can freely use any existing application. You can implement anything in that sense on, what others have, you can have it on Concordium. There's no limitation in that sense. But at the same time, you can use this ID on, on your applications to improve even the safety. Let's assume a scenario let's say in 10 years, there will be some, metaverses, and as a parent, maybe you may want to know who is dealing, your child, for example, who is dealing, your child is dealing with whom. This is the question that we are trying to answer. And we know that exactly, we know that there's a great opportunity for us. We know that when the regulation came, we will be ready. That is the purpose of being, of Concordium. Then when we say we are the most regulation ready chain, because we have the ID. And the confusion related to ID part is this. First of all, it is not KYC. It is an identification. KYC is something a little different. A KYC requires a full-fledged check background of your account. But what identity providers do for us is they just basically check the biometrics, like you provided your selfie and passport. They check if you are, if images are matched, then okay, they issue an ID object for you. So it's not a KYC. I need to clarify that part first. And let me jump into another question, because I believe it's slightly related to this from Buki. The data that is submitted before generating a key, it's owned by the blockchain, and is there a sort of governance over what can happen to that data? Also, can I delete the data if I choose to move away from the chain? So first of all, the key is not owned by Concordium, right? You transfer your items like passport photo and selfie through our wallets to the identity providers. They issue an ID object and they send it back to you. So the data is on your wallet and on the identity providers, and they encrypt it, and it is their job to make that data safe and secure, right? And the anonymity revocation process includes a legal party. So in order to trigger that, you have to prove that you have to have a court order, and then you can trigger it by a legal. There's a legal party, and using that legal party, you can invoke that process. So there is no Concordium involved in this process. For Concordium, you're only a public address, and you can do anything that you can, today do on other protocols. So from blockchain perspective, there is no differentiation. But if someone can prove that with that court order, then the mechanism itself, the anonymity revokers, can reveal your identity. Still, there is nothing related to Concordium. You need to go another flow, right? That's the first thing I need to clarify. And the second part of your question, Buki, you cannot delete an account on any blockchain, right? Let's look at this data structure in general. It is a state-keeping machine, right? When you create an account on any chain, what you do is when you type your seed phrase, basically you create a key pair, and then you deploy your account to a node, and through that node, it's distributed this in a decentralized fashion. So all of the nodes have your account, and it exists. Because of this data structure's immutability, you cannot take it back. It's not possible for you or for anyone else or on any chain to take an account back technically. So that I just want to clarify these parts. If you have more questions, I can gladly help them answer them.
Thank you very much. So there is another question. This has to do with the consensus mechanism employed by Concordium. So
Yes.
Onanike would like you to provide more insights on this and how it contributes to the security and scalability of blockchain network.
Okay. We recently shared a paper, and there's a good article recently published. I can send you a link, or maybe you can share with your with all the participants, and they can read it in detail.
But one of the things is that it works as a finalization. So you know that once it's a block is created, you know that, and people agree on it, then it won't be rolled back. So that is quite nice in terms of knowing that things are final.
All right, thank you. Another question here from Yuri is, can we find these smart contracts on GitHub?
Yes, you can. The particular one that I'm building now is also on GitHub. And we have a lot of example contracts in there. And we also have tutorials that cover how to build a lot of various smart contracts.
All right. Okay. Another question from Manao, sorry. Can I build IoTs, that is Internet of Things based solutions on Concordium?
Yes, you can reach out anytime to me or commercial team, and we can help you. We can discuss your use case.
Okay. So there is a question here from Mickey, and this is to Caspar here. So the question says, consider a scenario where you have a mutable reference to a struct in Rust, and you want to conditionally modify one of its fields based on some criteria. How would you approach this situation, ensuring both safety and flexibility in your code? Provide a code snippet demonstrating your solution and explain the key considerations in managing mutable references effectively.
Okay, so I'm just trying to, I didn't read the question at the same time. So you're saying you have a mutable reference to a structure like state, is that correct? And then you want to say, and then if you want to say if state does the place. Yeah. Now, then we want to say valid state that does here, like we'll empty it out, or so, I don't know if this makes sense. Yeah, some condition, right? Is that what you're asking? So we have a mutable reference to the state, and then we're checking something on here, and then we can mutate it. So here we're doing the mutation. Does that answer it? I didn't get exactly all the details of the question, so please, if you can expand, I'll gladly answer.
Okay, so I would allow Mickey here to unmute himself and explain better, or I could actually read the question, whichever works better for you.
Yeah, I mean, either way is fine. It's a written question. Did you say
yes,
that?
it's a reading question.
Okay, so there's here. Based on some criteria. I mean, yeah, okay, so that's exactly what I ensuring both safety and flexibility in your code, provide a code snippet. Yeah, so I guess this is you can also do, I guess you can also show it in a different way. So let's say R, and again, maybe it just has the state. This bar method owns the state now. So I guess one thing is that you can say we can make it mutable. So now we can mutate this state here, but we might want to create a helper method that is called Voni finished, for example. And it just takes in a it takes in the state as immutable, an immutable reference to the state here. So then you might say something like, if voting finished, the state here, then we want to do something. And then we might say that we are saying clear ballots or something. And that takes a state, but a mutable reference to the state. And then it says state ballots are clear. And then in here, we might, so if the voting has finished, then we'll say, what did we call it? Clear ballots, clear ballot here, and give a mutable reference to the state. So you see from this, we can see, okay, here we're calling some function here and checking it has an immutable reference to the state. So no, this won't change anything. So if voting hasn't finished, then the state down here, state 1 equals to, or state hasn't changed. If we're doing like this, state hasn't changed here. I know that for a fact because this just has an immutable reference. I don't even I don't need to know what voting finished does. I mean, I just wrote it, but if I call it like a library or something, I don't need to know what this does in order to see that it won't mutate the state because it can't. This is an immutable reference. And then in here, I'm pretty certain that this will actually mutate something. At least there's a chance that it does because I do give it a mutable reference to the state. So this is sort of a thing. I think this will answer the question. I hope this made sense. Any more questions?
No, I do not see any more questions here from my end.
Okay, cool. Should we just continue with a few more, bit more code and then stop at 11:45 as planned?
Okay, so not a question though. Someone is asking for the link where they can find the Rust smart contracts on GitHub.
Yeah. We will share all of the links we have with you afterwards, and then you can distribute it, Prosper. How does it sound?
I'm sorry, I missed
Prosper,
that.
can you?
I missed that. Sorry.
We can share all of the links we have with you, and then you can distribute it to the participants. Okay.
Okay. All right. That works fine.
Also have some.
Thank you.
Okay, guys.
The slides.
All right, guys. Now we should take a break, 15 minutes.